Hi everyone. Today we're going to look at another numerical method to solve polynomial interpolation. So we want to find the approximation for polynomial using polynomial interpolations. Okay, there are several ways to do this. Okay, but let's recall if anyone of you know what is a polynomial. Okay, polynomial of degree n can be written as this, where we have summation from I equals to 0 to n, a x I. Sorry, my I is not here. This is I should write it like this, x I, and an cannot be 0. I start from 0, right? So the a is the coefficient. So for example, if I have a polynomial for degree 2, I can write this as a0 when x to the power of 0 is 1 plus a1 x to the power 1, okay, so up to n, my n is 2 here, so plus a2 x2. So this is polynomial of degree 2. Now if I have, this is let me say this is n equals to 2. If I have n equals to 4, my p4x can be written as a0 plus a1x plus a2x2 plus a3x to the power of 3 plus a4 to the x power of 4. Okay, so this is polynomial. Okay, so interpolation here means, so what is interpolation? So let me just write it here. Interpolation means finding a function. We want to find a function from a collection of data. Okay, so the interpolation for this polynomial, we have polynomial interpolation. So you will have a set of data. I mean, can be anything. Let's say I have 0, 1, 0, 2, 0, 4, and so on. Okay, now from this data, what can be the polynomial? Okay, so you can say it might be degree 2 or might be degree 3. So we want to find out. We want to find out the polynomial that passes through a given set of data points. Okay, so we have a polynomial or interpolating polynomial. Okay, so let me give you one simple example here. Okay, so one example here will be let's say I have f0 equals to 1 and f2 equals to 2. Now how can we use this information to approximate fx for value of x in the interval? This is our interval 0, 2. Okay, so we have 2 points. So another way I can say that I can write this as 0, 1, 2, 0, 1 and 2, 2. Okay, these are my data. Okay, we have my x and my y, right? Without even finding the solution, if you have 2 points, you know your equation should be a linear function, right? So we assume we have a polynomial for degree 1 that looks like a linear equation, which is a0 plus a1x. Agree with me? Okay, now we want to find a0 and a1 so that we can get a good polynomial. Okay, so when x is 0, so when x is 0, so p10, I have a0. This is 0, which is equals to 1. Okay. Now when x is 2, p2 equals to a0 plus 2a1, and this is equals to 2. Now since we know a0 is 1, so I have 1 plus 2a1 equals to 2. So 2a1 equals to, okay, you know the answer is a1 is half. There you go. So now we can say that my polynomial is 1 plus a0 is 1, a1 is half x. There you go. Okay, so this is one way. A way to, for the given data set, we want to find the interpolating polynomial. Okay, consider another example here. So another example, given this set of data 1, 1, 2, 4 and 4, 5. Write down the polynomial for the given set of data. Okay, so we know we have 3 points, so your polynomial must be a quadratic at least of degree 2. Okay, so what we do, we just write down p2x is a0 plus a1x plus a2x squared. Okay, so if you have 2 points, like I showed earlier on, you will have a linear polynomial of degree 1, and if you have 3 points, we have a polynomial of degree 2. So similar approach, what we do is we substitute and find the value of a0, a1 and a2. Okay, let's start with x equals to 1. p21, we have a0 plus a11 plus a21 squared, and this is equals to 1. This is my, okay, don't remember, this is my x, this is my y, or in this case this is the p2, value of p2. Okay, so simplify this. I have a0 plus a1 plus a2 equals to 1. This is my first equation. Now the second equation for x equals to 2. So p2, I have a0 plus 2a1 plus 2 squared. So I have 4a2 equals to 4. Okay, so this is my second equation here. Now we have another equation, which is for x equals to 4. p24 is a0 plus 4a1, my x is 4, 4 squared, 16, equals to 5. Okay, let's write this in the form of a matrix. Okay, so we have 1, 1, 1, 1, 2, 4, 1, 4, 16. Okay, this is equals to a0, a1, a2. Okay, not equals, I mean, this is the matrix. This is a coefficient for a0, a1, a2, which is equals to 1, 4, 5. Okay, so it's not that difficult. If you solve this 3 by 3 matrix, you can find the coefficient a0, a1, a2. Okay, so you can write this as your big a. You can write this as your little a, and this is, I don't know what you want to write. Maybe this is your, oh, we always do this, okay? If you remember this, let's do this. So we always write this ax equals to b, okay? Now, to find x, which are all the a value, we need to find a inverse multiply with b. Okay, so the easy way is to press the calculator and get the a inverse multiply with b. So my quick calculation using the calculator leaves me with my x values -3.667, 5.5, -0.8333. So I'm not showing you how to find the inverse of a. You can use any online calculator to get the inverse of this big 3x3 matrix, or you can use Cramer's rule, or you can use elementary row operation, anything, or you can even solve simultaneously. Okay, it'll take a while to do that. Okay, so what this means? This means that this is my a0, this is my a1, this is my a2. So my polynomial can be written as a0 -3.667 plus a1x 5.5x plus a2x squared -0.8333 x2. So this is the polynomial for given 3 set of data. So it's interesting actually, because this approach that also similar or exactly the same as the one known as Vandermonde approach. So you can Google it or look at my lecture note on page 199. Where Vandermonde approach, we can write one big matrix X. The first column start with 1. The second column is your x0, x1 up to xn. And the third column will be the square of this. So we have x0 squared, x1 squared, up to xn squared, and it can go on up to x0 to the square of n, xn to the square of n, up to xn to the square of n. Okay, and then you find, similarly, you want to find the value of a. So a will be x inverse y, and y is the y values from a given data. Okay, so we can look at this maybe in the next video. Okay, that's all for today. Thank you.